Hello pre-calculus students, and welcome to a video that reviews sum of factoring. Now notice it says factoring review 1. There's 3 parts to this. And so we're starting out with the easiest stuff. Everything on here is from Algebra 1. We're going to move into something that's sort of the overlap. Number 2 will be the overlap of Algebra 2 and a little bit of maybe the harder stuff from Algebra 1. And then the third part will be the harder stuff from Algebra 2. And then sort of easing into the some of the stuff that's you probably haven't seen before. Okay, so let's just start out with the first skills here. So the first skill in factoring is just factoring out the GCF. And so when we have something like these example 1 A and B, we just start out by, we want to get rid of the negatives. So I'm going to look here for a common factor, and I realize that there's a negative 8 in both. So I take that out. And then I ask myself that question, what do I multiply negative 8 by to get negative 24k to the 5th? And that is going to be positive 3k to the 5th. And I always kind of go forward and backwards. So once I take that out and I multiply, I just kind of think to myself, is that right? Is it negative 8 times 3k to the 5th? Is that negative 24k to the 5th? And if I get a no, then I would erase, and I'd be in trouble since I'm using a pen. What do I multiply negative 8 by to get negative 64? That would be a positive, or a plus 8, right? Negative 8 times 8 is negative 64. So there it is, and that is a fully factored problem. Okay, let's try the same thing with this. The GCF in all 3 of these, the number part is 9, and the variable part is B. So let's, why don't you guys work ahead. We've done this before, just to see if we match answers. Okay, so there it is. Now, since this is a review, I'm just going to kind of think this through with you guys. Once you recognize what the GCF is, you can kind of rewrite this like this. This is 9b times b to the 5th. This is 9b times 10b squared. I mean, just times 10b. And then this is 9b times 5. And I'm only showing you this because the middle process here, the middle step would be to actually say, okay, I'm factoring each one of these terms. I'm writing it as the product of 2 different things, right? And each time there's this common factor. So that's how you factor these. You have to identify the greatest common factor in all 3 terms. So I pulled out the 9b, and notice that everything that's not circled, that's what goes inside the parentheses. You do have to be careful if there was a 9b times 1 here, because people do sometimes forget to put the 1 inside the parentheses, but I just did not think to make an example like that in this paper. Okay, the next type is a difference of 2 squares. Difference of 2 squares pattern, you might remember, is that a squared minus b squared. If you're subtracting 2 squares, it's just going to be a minus b times a plus b. So to do this, you need to identify what's being squared before you can apply the rule. So here, what's being squared is 2x, right? I'm going to rewrite this as 2x, that's what's being squared. Minus what's being squared here is a 5. So this is essentially my a and my b, and so I'm going to go 2x minus 5 times 2x plus 5. Once you see it in this form, and it does match back up, and don't forget about parentheses, little things like that can trip people up, then we've got it. So this is going to be 2x minus 5 times 2x plus 5. Okay, let's try that with this example right here, difference of squares. Okay, so there you go. First realizing that this is 3x being squared and this is 2 being squared, and they're a difference. There is no way of doing this if there were a sum, by the way. You can't factor if it's a sum, unless there's a GCF, like the first example. Okay, so let's look at factoring trinomials. Now, you guys have learned this in a variety of ways, but at this point, because it's going to be something that's kind of basic when there's no leading coefficient, I'm going to show you the way that I think is the fastest way to do it, which is if there's no leading coefficient, then you can just start out with, you know there's going to be 2 brackets if there's all 3 terms. There's a v and a v there. That's the only way to get v squared. And as far as these, you might have seen these little x factors. So we make a little x, and we need to put this number at the top, so negative 18, this number at the bottom, so positive 3, and we need a product. We need two numbers that give us a product of negative 18 and a sum of 3. We just need to come up with those two numbers. So we have to think through different factors of 18, negative 18, that add up to 3. So you think like, well, 9 times 2 is 18. Negative 9 times 2 is 18, but that's not going to give me a 3. But if I did negative 6 times 3, well, if I do a 6 times a 3, then, well, the difference is 3. I have to make sure that this is the positive and this is the negative. So that would be the positive and that's the negative. Now, just think it through. This is a product of negative 18 and this is a sum of 3. Once you have your numbers, these are the numbers that go in here. So plus 6 minus 3. If you really don't like that and you have another method, that's fine. But just be aware that these are going to be kind of common and they're going to be kind of quick. We don't want this to be a long process because it's not going to be the whole problem. It's going to be a small part of a longer problem. All right, so let's try it with this one. Okay, there we go. Now, when I do this in Algebra 1, which I haven't done for a few years, but when I do this, I just start out with these. I just give a bunch of these x's. I call them magic x's, and I say, find the two numbers that give me a product of negative 40 and add up to negative 3. And they just have to search through the different factors until they find one. Once it's there you go, plus 5, and it is factored. Okay, let's look at factor by grouping. Now, with factor by grouping, that means we're going to take two groups. Now, some of you do the other example by grouping. You create a fourth term, so you might be familiar with this, but you should all be familiar with it, but it might even be more common for those of you that learned how to factor this way. I make two groups. I take the GCF out of each group. So the first group, I have a 3x squared that comes out. And what's left inside. So in order to do this step, you have to be already good at factoring by GCF, taking out the greatest common factor. So this would be a 2x. This would be a, maybe 3 doesn't come out of there. Let me redo that. I'm talking too much and thinking too little. Let's do that again. The GCF of these two terms is just going to be, 3 doesn't go into that, 2 goes into both. So it's going to be 2x squared. And then I multiply 2x squared times 3x to get that term, and I multiply it by negative 8 to get that term. Okay? And then the other group is going to have a, let's see, what's common to both of these would be a 5. So I'm going to take a 5 out, and that leaves me with a 3x, and then 5 times what equals negative 40? That's negative 8. Now when I did this, notice what happened. And this is when factoring by grouping works nicely. Otherwise, we might have to rearrange the order of the terms where we started, but usually this will work. Those are a GCF. So therefore, I'm going to pull those out in front. Same thing I did over here, right? I found the common factor, and I pulled it out in front. Everything else went inside. So that's what I'm going to do here. I found the common factor. I'm going to pull 3x minus 8 out in front. Everything else, 2x squared plus 5, that's the rest of it. And that's it. Factor by grouping. Okay? Let's try it with this next one. I usually will make a negative in the middle there into a plus and negative, just to sort of make sure we don't make a mistake with those negative signs. But let's try it. And I'm going to pause it, and we'll compare answers. Okay, so there it is. First I made this plus and negative just to sort of make it easier to look at. I carried that plus down. I factored out a negative 6 from these two terms. I end up with 2x plus 1, because if I multiply negative 6 by what to get negative 12x, I come up with 2x. Multiply it by what to get negative 6, I come up with 1. And that's the same factor for both of these. Came out in front. And then x squared minus x squared plus negative 6, which is x squared minus 6, is left over inside. All right, let's look at the next example, which is when we have a couple of steps here. So the first step, always, if there is one, the first step is always to take out that GCF. And so hopefully you just always scan every problem for a GCF, and this one has a 5. So I'm going to start out by taking the 5 out in front right off the bat. So I get n squared minus 7n plus 10. And then it says factor completely. It's kind of a hint that this might not be completely factored. This is a trinomial just like example 3. just a trinomial, we need to be able to factor that into two more pieces. So let's do that with this trinomial. So I've got the 5 times these two more pieces. I know because this has no leading coefficient that these are both going to be n. And I know that these will be a product of 10 and a sum of negative 7. So the only way to get a product of 10, we can make a quick x factor. We need a positive 10 and a negative 7 for the sum, and that's just going to be negative 5 times negative 2, right? Negative 5 times negative 2 is 10, adds up to negative 7, minus 5, minus 2. Now it is factored completely. Okay? Let's try B. I'll pause the video, give it a try. Okay, so I took out the negative 4. I end up with this trinomial. I need a product of negative 7, which I put up here, and a sum of 6. I came up with 7 times negative 1. That's a product of negative 7, and adds up to 6. So the m's are automatic here and here. I just found the plus 7 minus 1. And there it is, factored completely. Okay, let's look at the last one here. And now this is solved by factoring. So solved by factoring means first factor, and then use the fact that the product, the zero product property, which we'll just work this one through and I'll talk about it even though I know I have already this year. So we're going to set it equal to 0. The trinomial we're going to set equal to 0. So I'm going to leave that n squared where it is, subtract 3n from both sides, subtract 4 from both sides, and I've done the first step, which is setting it equal to 0. Now I'm going to factor this, which I know is going to, it's just a trinomial with no first term. And I'm just going to factor it. No first coefficient, so n and n. I need a product of negative 4 and a sum of negative 3. So product of negative 4, sum of negative 3. What multiplies to give me negative 4? How about negative 4 times 1? That multiplies to give me negative 4 and adds up to negative 3. So that's what goes here. Minus 4 plus 1. The zero property of multiplication says if I'm multiplying two things that are now multiplied, they weren't before, right? They were added and subtracted. Now they're multiplied. The only way to get a product of 0 is if either this one's 0 or this one's 0. So I say n minus 4 equals 0 or n plus 1 equals 0. So n either equals 4 or negative 1. And that's the only solutions to this original equation. That's the only values that will make this a true statement. Right? You guys can try example 2 here. So pause the video and we'll compare notes. Okay, so there you have added 5 to both sides, broke it up into the two parentheses. I was looking for the 8 and 7. If you don't just want to do it in your head, you can make a little x factor, product of 56 and a sum of 15. 8 times 7 comes right to mind, hopefully for you guys too. And then when you solve this using the zero property, either this factor is 0 or this factor is 0. And so you find both solutions, negative 8 and negative 7. Okay, I hope you found this video helpful. And if not, you already were masters at factoring at this level. The next one will be factoring at a slightly higher level where we do have a leading coefficient and we're going to add on. Okay, so have a great day. Hope you found this helpful.